This lesson is going to discuss symmetry as well as even and odd functions. So first thing we need to give a definition for is symmetry. This is something you can kind of see geometrically when you fold something in half, either vertically or horizontally, and things kind of match up on both sides. The other type of symmetry that we have is when something rotates. So if you look here at this second graph, if you were to rotate this thing around, then it would look exactly the same. So let's get a mathematical definition for symmetry. So symmetry is when one shape becomes exactly like another when moved in some way. And typically those ways are flipping, so that would be kind of folding along that horizontal or vertical line to get things to match up. Turning, like we said, or possibly sliding, but we're not going to be dealing with that as much in this section. So, like I said, if we look here at this function 3x squared, we've got what would be called our line of symmetry here, the y-axis. If you fold this in half, or if you flip this right side of the graph over, it'll match up with the left side of the graph. So this point here matches up with this point here, so forth and so on if you were to fold those in half. Rotational symmetry is what we're going to be looking at. Again, this is what we would call reflective symmetry. Rotational symmetry is, like I said, if we were to rotate this thing, if we look at this point here, for instance, it's going to match up with this point down here. If we rotate it around, this point would go here, this point would come up here, and you'd get the same thing. So this would be what we would call rotationally symmetric. And this gets to our definition. This helps us when we're trying to determine if a function is even or odd. So a function is called even if it is that reflective there. An even function is even if for every input x, f of x is equal to f of negative x. So if we come back up here to this graph here, we can see that if, for instance, we plug in x equals 1 and follow that up on the graph, and if we plug in x equals negative 1, those 2 points end up being at the same height, the same y output value. And so in this case, they're even. Another way to kind of easily tell is that this has an even exponent, x squared, and so that is an even function. We also say that this is symmetric about the y-axis. So again, like I said, you're folding it in half along the y-axis. So then if we want to talk about odd functions, these are going to be the rotationally symmetric ones if for every input x, there's two different ways you can write this, f of negative x equals negative f of x, meaning that if you plug in a value, say 1, and then get that number and then make it the opposite sign, you're going to get the same thing as if you plugged in negative 1 to the function. So again, this is another way that sometimes this is written is that f of x equals negative f of negative x. Again, this doesn't mean we can pull negatives out of functions. This is just saying that if we plug the value in and then make it negative, it's the same thing as if we plugged in the negative number to the value. So this is called symmetric about the origin. So if we want to kind of see this on the graph, you can see how, again, if we were to, for instance, look at plugging in -1 here, we should get -1 because -1 cubed is -1. And then if you plug in 1 up here, you get 1, and if you were to make 1 negative, you would also get -1. So that's what this is saying here. So let's take a look at some examples now. We want to determine if a function is even, odd, or neither. So like I said, a lot of this can also be kind of attributed to exponents, but let's make sure we prove things mathematically. Let's take a look at this example. So we've got x squared minus 1. Is it even, odd, or neither? Again, looking squared gives us an indication it should be even, but let's make sure because there's that -1 there. So what we're going to do is we are going to plug in -x and see what happens. So if you plug that in, you get -x quantity squared minus 1. Again, anything squared is going to be positive, so we just end up with x squared minus 1, which, hey, was what we started off with. It's f of x. So in this case, we know that this function is even. Try another one here with you. We've got x cubed plus 5x. Is it even, odd, or neither? Again, we've got an odd exponent 3 and an odd exponent 1. So we'll plug in f of -x, see what happens. -x cubed plus 5 times -x. -x cubed is -x cubed. 5 times -x is minus 5x. And if we factor out a negative here, we end up with x cubed plus 5x. So we've got that negative there, which is really negative f of x. So again, pulled that negative out. So we're left with x cubed plus 5x, which is the same thing that we started off with. There's just a negative out front, which means it's negative the original function. And so in this case, this means we have an odd function. So I want you to pause the video here and try the next example, and then resume the video to check your answer. So you should have worked out that when you plug in the negative, you end up getting the original function back. Again, we've got an even exponent x to the 4th and an even exponent x squared. Both of those are even, so we end up with an even function. Let's try one more here. Again, pause the video and then resume it to check your answer. So in this case, plugging the negative in, we end up with -2x cubed plus 8x squared. If you pull the negative out, that's going to make this minus 8x squared. So you're never going to be able to do anything to make those signs match up. Again, if you notice, you've got an x cubed and x squared. One of those numbers is even, one of those numbers is odd. And so in this case, we have a function that is neither even nor odd. So this covers symmetry and even and odd functions.